all, be sure that you are looking at those laws and the property if you don't know them, because again, you might use 2 or 3 of them at the same time. You might use one of them 2 or 3 times. It just depends on the problem. There's no way to say a problem like this, you're always going to use this. It just depends. Okay, so these first two, notice they're in radical form, and the directions do not say change to exponential. Sometimes you have to change to exponential to simplify, but if it starts in radical form and there's any kind of radical left, that's the one time where you might have multiple x's. You could have x's on the outside of the radical and on the inside. If it doesn't simplify, like to where the radical goes away, like the square root of x squared would just be x, the radical goes away, then you need to leave it in radical form. Okay, so if it starts in radical form and it says simplify, your answer should be in radical form unless they go away by simplifying. If it starts in exponential form, you need to leave it in exponential form unless the directions specifically tell you, like yesterday, change radical to exponential, exponential to radical. Okay, so these just say simplify, and you can't have still no negative exponents. Okay, so first of all, the fourth root of 81. You should know some of your perfect cubes and perfect fourths. Just like you all know your perfect squares, you should know that 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. You should also know some of your fourths. So the fourth root of 81, 81 is kind of one of those special numbers that's a perfect square and it's a perfect fourth. 64 is a special number also. It's a perfect square and a perfect cube. So just be aware that there's some of those that are a little bit tricky because they have multiple perfect roots. So the fourth root of 81 is 3. Okay, because we can do 3 times 3 times 3 times 3. We have a group of 4 3's, and that pulls out as 3. The way that you simplify the variables with exponents, a couple ways you can think of that. You can change it to a fraction, okay, an exponent, and do that. Or the easier way to do that is just know we have a root of 4, and we say 4 goes into 8 how many times? And that's how many you bring out. Whatever's left over, basically the remainder, is how many stays under the radical. So 4 goes into 8 2 times, so we bring out an x squared. 4 goes into 4 1 time, so we bring out a y. Because there's 4 y's. We're looking for groups of 4 things. So y to the fourth is 4y, so it comes out as y. So we don't have any radicals left, so you're done. The next one, the best thing, or the easiest, the way I would do that is because we have a cube root and we have 2 separate kind of, not terms, but 2 separate parts to it, I would combine those parts into one before I start simplifying. Because if you start simplifying little bitty things and then trying to combine them, you don't always combine them correctly. So since these are both cubes, cube roots, I would say the cube root, as long as you're taking the cube root or square root or fourth root, whatever, of the same thing, you can multiply anything together. So x times x to the fifth is x to the sixth. Y squared and y is y to the third. Z and z is z squared. So now, in my opinion, it's a much easier problem to simplify than having a bunch of stuff you have to try to combine together. So now we just do like we did on number 1. 3 goes into 6 twice, so that's x squared. 3 goes into 3 once, so that's y. 3 does not go into z at all, so it has to stay. We can't do anything with that. It's like the square root of 7. We can't take the square root of 7, it just has to stay. So the cube root of z squared. So this is one of those, it started as a radical, the directions just said simplify, so that's what we did. It did not say change to exponential, so we just want to leave it in radical form. So those are a little different than what we did yesterday. These are all kind of 3, 4, 5, and 6 are kind of all the same as what we did, so I'm going to do 5 and 6. If you want me to go back and do 3 and 4 with you or check it or for you, I will be more than happy to do that. All right, so number 5 and 6 kind of combine everything in 4, 5, and 6. So 2x to the fourth, y to the negative 4/5 to the third. You could cube everything. You could move this down and then cube everything. It's kind of up to you what you want to do. What I want to do is get rid of that cube first. So I'm going to make that 8. Power to a power we multiply. Power to a power we multiply. We do not multiply the 3 times the numerator and the denominator. That would be multiplying by 3 over 3. And the exponent is just 3, so it's like 3 over 1. So that becomes negative 12 over 5. And then we have times 8 to the 2/3, y to the 4/3. And you can do as many steps as you want. If you just want to do one thing at a time and not do multiple things, that's fine. So we have 8 and 8. That's not 64, okay, because this is not 8. This is 8 to the 2/3. So we need to take 8 to the 2/3 and figure out what that equals. So it is the cube root of 8 squared. Remember, this is the power, this is the root. In order to evaluate a number, even though it's not going to tell you to change it to radical form, that's what you need to do. Unless you start getting familiar with some of those, some of them you'll see so much that you'll start to know what they are without having to do that. That's fine. If you have to write it down, write it down. I always write it down because it is so easy to flip-flop that 3 and that 2. If you don't write it down and do it wrong in your head, it messes everything up. So this one's pretty easy to go either way. We can square the 8 and take the cube root, or cube root of 8 and square it. Either way, it gets you the same answer. So the cube root of 8 is 2, 2 squared is 4. Or 8 squared is 64, cube root of 64 is 4. Either way will work. This one, again, is not big enough to where it really matters which way you do that. So this right here, so we have 8x to the 12th, and then this is 4. And then we still have our y to the negative 12/5 and our y to the 4/3. The x is all by itself, so we don't have to worry about the x, but the y's we have to combine. So, a couple ways you can do that also. Just kind of depends if you like to use the divide like bases law or the multiply like bases law. Multiply like bases, you add the exponents. Divide, you subtract. Whether you like to add or subtract, it's up to you. So, the reason I say that is because we can move this to the bottom, get a common denominator and subtract, or we can leave it here, get a common denominator and add. I like to multiply like bases and add the exponents. I think that's easier than trying to figure out when I subtract whether it goes to the top or the bottom. So I would get a common denominator first. So over here, this is going to be negative 12 over 5 times 4/3. So this needs to be multiplied by 3 over 3. And 5 over 5. So this ends up being y to the negative 36 over 15 times y to the 20 over 15, which gives us y to the negative 16 over 15. So what I have right now is 8 times 4. I can go ahead and do that. 32x to the 12th, y to the negative 16 over 15. But we can't have negative exponents. So now I need to bring that to the bottom. So my answer would be 32x to the 12th over y to the 16 over 15. No negative exponents. So again, no negative exponents and no variables repeating. So if you had an x in the numerator and the denominator, or 2 x's in the numerator, that's how you know I need to go a little bit further. Okay, no negative exponents. Those are the two main things to look at. No negative exponents and no variables repeating. If you have variables repeating, that means you're not done simplifying yet. And number 6 is really kind of simple, but because of all the negatives, it can get confusing. When you do this, you need to do one thing at a time. Okay, so it doesn't matter which one you do first. You can do these insides, make everything positive, or you can do this outside, make this outside positive. That's what I would do. So I'm going to do this one first. So if I do that, negative 1 to make it positive 1, I flip everything inside. I keep everything inside as it is, I just flip it, and then that just becomes to the first. So basically, that exponent we can ignore, because anything to the first is itself. Now, I have negative exponents. Okay, this negative 1/3 is only attached to the b. If there were parentheses, it would be attached to both, but there's not parentheses, so it's only going to the b. So the 4 stays 4. We don't move the 4. The 4 stays, the 3 stays, the a to the negative 2 comes up, b to the negative 1/3 comes down, and there is your answer. Something you did a little different in Algebra 2 is, I don't think they let you have fractional exponents in the denominator. Okay, we would rather you have one letter, so just leave it just like that. Okay, if you have a repeating letter in the numerator and denominator, that would not be considered simplified. All right, so now something a little different than yesterday, like basis. You did like basis in Algebra 2, probably doing a little bit more than what you did in Algebra 2 in pre-cal, but you have to know how to get like bases. When you get like bases, you always want it to get to the smallest number. You could rewrite 9 in a different way, and it still be equal to 9. Okay? 3 squared equals 9. Those are equal, right? It's the same thing. I can't rewrite 3 as a 27. I can, just not as easily as I could go the opposite. It's a lot easier for me to rewrite 27 as a 3 than a 3 as a 27. So whenever you're doing anything like this, you want to get like bases. And we're going to use this to solve in a minute also. So all of these bases need to be the same number. Once they're all the same number or the same base, then you can apply the rules. So 3 is the base we're going to use. 9 we can change to 3 squared. 27 we can change to 3 cubed. And all of the other exponents stay where they are. If you put it around the 4, then it would look like 24. Right? And that's not 24. So it would not be correct to say 24. Okay, so you're changing 9. So right now 9 is being raised to the 4th. So we want to be sure and put parentheses around the 3 squared. Just like if I said what we did previous, like if I said x squared and I want you to say replace an x with a negative x, we would need to put the negative x in parentheses because that's what we're replacing. Okay. Anything else so far? All right, so now I just use my laws. 3 cubed stays 3 cubed. Power to a power we multiply. Power to a power we multiply. Now we can add, because we're multiplying like bases, so 3 to the 11th over 3 to the 12th. Remember, that 3 is just the base. It's like it was a letter. X, Y, A, B, whatever it was. So if we have 3 to the 11th on top and we have 3 to the 12th on bottom, we can use our law, we can use just our common sense of simplifying, what we do a lot, or we can say that is 3 to the 11 minus 12, which is 3 to the negative 1. We can't have negative exponents, so that ends up being 1/3. Be sure you don't leave a 3 on top. It's not 3 over 3 to the first. 3 to the first is 3. So if you say 3 over 3 to the first, that's just 1. Okay, don't get confused with the 1 as the exponent. All right, 2, using the base of 5. So if I change this to a 20, that's not a problem that could be done, okay, without a calculator. Because you can only use like bases if you're able to change them to like bases. If this 27 had been a 28, it's no longer a problem that would even be given to you. Or be a problem you have to do in the calculator. You just have to type it in. So if you have a problem like this, and you're talking about the same base, you want to change the bases to be the same. And very important that you change it to the small number. Because every year I have people say, oh, well, I'm going to make them all 125. And then they change 5 to 125. Or they change this to 5 cubed. Okay, well 5 cubed doesn't equal 5. 5 cubed equals 125. So you can't change the value of the problem, you can just change what it looks like. So 125 is 5 cubed. The negative 3 stays. 25 is 5 squared. 5 to the negative 8 is just still 5 to the negative 8. So all the bases are the same. And you always want to make the base that small number. And those can be, they can be fractions. Sometimes on these, when you're getting the same base and you're solving, you have to change it to a negative in order to get the base to be the same. You just have to recognize, and that's why it's important to recognize your perfect squares, cubes, thirds, and fourths. The fifths, you probably only need to know 2 and 3 to the fifth, nothing past that without a calculator. So this ends up being 5 to the negative 9 times 5 squared over 5 to the negative 8. And whatever you like to do. Do you want to get rid of the negatives? Do you want to combine and then deal with that? Lots of different ways you can do that. You don't like the negatives, you want to get rid of the negatives before you do anything. Alright, so 5 to the 8th comes up, 5 squared stays, 5 to the negative 9th comes down. And then you end up with 5 to the 10th over 5 to the 9th, which is 5 to the 10 minus 9. So you just get 5. However you want to do that. You could have, at this point up here, said negative 9 plus 2 is negative 7, and get 5 to the negative 7 over negative 8. Negative 7 minus negative 8 is 1, and you would have got 5 to the first then as well. Lots of different ways to go about getting to the answer, but that is the answer. If you get a different answer, the way you went about it is not correct. This one has still the 5s in it, so same base, but it's got some variables and a cube root on the outside. But everything is the same, so just ignore that cube root, or not ignore it, but just put it there. We're not going to deal with that yet. And change everything to the like base. So 5 cubed to the n. 5 to the 4n stays. 5 squared to the negative n. So before you worry about that cube root, do everything that's inside. So I don't want this to be negative, so I'm going to go ahead and bring that negative up to the top. So 5 to the 3n times 5 to the 4n times 5 to the 2n when I bring it up. It was negative 2n on the bottom. Bring it to the numerator, and it becomes positive 2n. So all I did was multiply 3 times n, and multiply 2 times negative n, and then bring it up to get rid of that negative exponent. Now I still have all this underneath, so the cube root, these are like bases, so it's not 125, it is 5. Add the exponents to 9n. Now this started as a square root, so we want to leave it as a square root unless you can simplify it. So 3 does go into 9n, so we could make this 5 to the 9n over 3, which is 5 to the 3n. If this had been 8n, we would have left it where it was, because 3 does not go into 8. We'd be done. If it goes in, you need to simplify. If it doesn't divide in evenly, you can leave it. You don't have to go any further. Alright, so now using those to solve these equations. So tomorrow when we start talking about logs, and then Monday we start using the calculator, this is just like kind of everything else that we've given you. Depending on what numbers we give you, depends if you need a calculator or not. Number 1, if I would have changed this 8 to a 10, that becomes a calculator problem. Okay? The only reason I can do this without a calculator is because I'm able to get the bases the same. So if we give you a problem like this that you don't have a calculator, it means you can change the base to be the same. So I can change 8 to be 2 cubed. 2 cubed equals 8. All I've changed is the way it looks. Raised to the x equals 2 to the 6th. So 2 to the 3x equals 2 to the 6th. And if we just use common sense at first, even if we don't know the rule, if we just looked at this and I said solve for x, hopefully you'd see these numbers are the same. If this is equal and these two numbers are the same, that means those two numbers have to be the same. So what value of x makes those two sides equal? 2. And if you have two bases that are the same, you just set their exponents equal to each other. 3x equals 6, and you can just say 2. Now, I don't care if you show me 3x equals 6, but as long as the bases are the same, you can do that. Now, if that 8 had been a 10, you have to use logs and a calculator, and you can go from there. And it's not a difficult problem, but it's just makes it to where you can't do it without a calculator. Okay, even though it looks like 10 to the x equals 2 to the 6 would be something you could do, you can't. All right, now these next few problems are a little different because this first one has a negative exponent. So our goal is to get x by itself. Well, in order to get x by itself, we first got to get rid of that 8. So x cubed equals 8. Negative cube, sorry. There is no such thing as a negative cube root. Okay, you cannot take a negative cube root of anything. That is not anything that is even mathematical. So we have to get rid of the negative. Before you do things, like yesterday, before you changed from the exponential to radical, you had to get rid of the negative. Because it's not just 8 is not the base on the other side. So the other side, the base right now is 8x. On that first one, the base was 8 and the base was 2. And this one, it's 8x. So here the x was in the exponent. Here the x is not an exponent. So it's kind of like going back to normal, the way that you would solve anything. Okay? So the reason we wouldn't make this 8 squared is just because that doesn't do anything for us. The only time we have to change the base, that's a good question, the only time you have to change the base is when the variable is in the exponent. If the variable is not in the exponent, you're just doing a regular problem. Okay? If the variable is not in the exponent, there is no need ever to change the base. Only need for changing the base is when the variable is in the exponent. Okay? So 1 over x to the third equals 8. Now, yesterday all we had were simplify, evaluate. Okay, we didn't have any solve because there weren't any equal signs. On your homework, there was one that said the square root of 8, and the square root of 64. So many people, some of you might have even put plus or minus 8. The square root of 64 does not equal plus or minus 8. Okay, we haven't changed the rules. They didn't hide that from you in 7th and 8th grade when you first started learning your perfect squares. The square root of 64 is 8. Now that we're solving things, that's when it could be plus or minus. Okay, only when you're solving and you take the square root of something or the fourth root of something is when you have your plus and minus signs. Okay, not when you're just simplifying or evaluating. All right, so I would make that a proportion and then just cross multiply, or you can multiply both sides by x to the third, doesn't matter. So we have 8x to the third equals 1. X to the third equals 1/8. So now it's in a form where I can solve it. Now I can take the cube root, because the cube root is a thing, the negative cube root is not. Cube root. Now when I take the cube root, is that plus or minus like square root? Correct, it is not. Okay? It's just either plus or it's minus. It's not plus and minus together like a square root. So this is just x equals cube root of 1 is 1. We can take the cube root of 1, the fifth root of 1, the 782nd root of 1 is still 1 over 2. And there's your answer. Again, maybe some different ways to go about doing that. As long as you get the same answer and everything that you did is correct mathematically, then that is fine. Just make sure what you do, the work you do, is correct. All right, very similar problem, except now in the parentheses is an 8 plus x. We can't subtract 8 yet because all this parentheses is attached to that negative root 3. We can't take the square root, the negative third root of anything because that's not anything that's possible. So the first thing we do in this one is get rid of that negative exponent. The way to get rid of the negative exponent is bring it to the denominator. Now we still can't just take the cube root because we have that 1 in the numerator. So we need to do what we did last time. Cross multiply. Divide by 64. And now we can take the cube root. We don't ever want to actually cube all of that. Okay, 8 plus x times 8 plus x times 8 plus x. That's not something we want to do. That just gets us to a place where we have to find the factors. So then you have to use the rational root theorem, the p over q, find all your possibilities. And I don't want to do that anymore. I know most of you don't want to do that anymore. Okay, so don't cube or square things. Just leave it as it is and get rid of that cube by taking the cube root. And if you don't have a calculator, these are always going to be nice, perfect cube roots for you to simplify. So you end up with 8 plus x. Cube root of 1 is 1. Cube root of 64 is 4. 64 again is one of those. It's a perfect square and a perfect cube. So don't get those mixed up. And then we subtract 8. So you get x equals 1/4 minus 32 over 4. So x is negative 31 over 4. Just getting a common denominator and combining those two together. Alright, and then these last two, again, just some more solving that look a little different. This one has a fraction to it, so 2 times x to the 3/2 equals 54. Very important that you divide by 2 first. You can't get rid of that 3/2 before you do anything. Some of you, when you solve, you're forgetting the order. It's kind of like undoing the order of operations when you're solving. Simplifying, use the order of operations. Solving, kind of backwards. So we have to divide by 2 first. So we get x to the 3/2 equals 27. Now from here you can change that to radical if you want. Or you can just, we've got to figure out how to make that exponent 1 on the left side. So the way to make that exponent 1, the easiest way, is to raise it to the reciprocal. Just like if you had 3 over 2x, you would multiply by 2 over 3 to get it to be 1x. We already have 1x, we need an x to the first. So x to the first would be times 2 over 3, because 6 over 6 is 1. If we multiply one side by 2 over 3, we have to, or raise it to 2 over 3, we have to raise the other side to 2 over 3. As long as we do the same thing to both sides. And we can only do that when there's an equal sign. If there's not an equal sign, we can't just do anything to one side. Someone yesterday had the problem like 4/9, and they're like, well, can I take the square root of that? No, don't take the square root of it. It's just 4/9. Okay, don't confuse that with an equal sign. If it was 4/9 equals something, then we can do whatever we want. We could add 12 to both sides. Multiply both sides by 3/2. We can do whatever we want to both sides. We just want to make sure it gets us somewhere. So x equals, we can say this is 27 squared. Cube root, because this is the power, this is the root. And again, you'll see these numbers happen over and over again, because there's only so many numbers we can give you that you can do without a calculator. You're going to see to the 2/3, 3/2, 5/2, 2/5. You're going to see those things happen over and over again, and some of you will just automatically learn what they're equal to. So here I take the cube root of 27, which is 3, and square it. So x equals 9. And you can check your answers on this. So 2 times 9 to the 3 over 2 equals 54. So that's 2. 9 cubed, square root. Square root of 9 is 3. 3 cubed is 27. 2 times 27 equals 54. So what's nice about the solve is you can plug it back in and check to make sure you did it right. Alright, and then here divide by 4, so x plus 2 to the negative 2 equals 25. Then we can't do anything with that negative. We have to get rid of the negative before we start doing things. So 1 over x plus 2 squared. I shouldn't say we have to. There are other ways to do this. You don't have to get rid of the negative, but I will say it's easier to remember some of the tricky things if you get rid of the negatives first when you do a problem like this. All right, so then we cross multiply. 25 x plus 2 squared. Do not square x plus 2. Okay, there's no need to do all that. So we get x plus 2 squared equals 1 over 25, because we divide by 25 on both sides. Then we can take the square root. Whenever you take the square root, that's when it's plus or minus. If the square root's already written, you don't add a plus or minus to it. But if you put the square root on, that's when it's plus or minus. Okay, very important to know that. That's where some of you are getting mixed up. You just think square root, it's always plus or minus. That is not the case. If you take the square root of something, so the square root was not on this problem, I had to put the square root on this problem. That's when it's plus or minus. If the square root was already there, you don't put a plus or minus on it, because then you're changing the problem. So then I get x plus 2 equals plus or minus 1/5. Square root of 1 is 1, square root of 25 is 5. So we have two answers that we can find. X equals 1/5 minus 2. X equals negative 1/5 minus 2. You have to actually find those. If you don't, that is not correct. If it was like the square root of something, plus or minus 1/5 minus the square root of 2, that's different. But it's just numbers that we can do without a calculator. So you just need a common denominator, so 10/5. So we get negative 9/5. 10, negative 11/5. So we have two answers on that one. So that's when it's square root.